Today with this lab, I'm going to go over the instructions. We will spend about 20 minutes getting this lab ready. As you are pretty familiar with, it takes a second for me to explain everything. So the first thing I'd like for you to do is pull up the actual document that's the activity. So the assignment, that's the third one in the Canvas day one. And this is going to have the general instructions. We're going to go over that, and then we're going to go do the things. All right, so this will largely take you a good bit of time for data collection. So just be prepared for careful data collection. You're going to follow the link in the momentum and collisions file. That's the actual document that you're going to have. I would say open it in Google Docs. Yeah, Google Docs would probably be your best bet because you're just going to edit it in Google Docs. You don't need Kami for this one. All right, because it's just entering numbers and then answering some questions. So you're going to open that file and you're going to open the actual lab link. It's going to link you to a lab. It's going to be one of the physics classroom interactives. You'll open the spreadsheet link in Canvas. It's the one that says spreadsheet. And the first thing you need to do is make your own copy. Do not edit the original, please. So you're going to make your own copy of that as soon as you open it, and then open it in your Google Drive. You will follow the directions in the lab document as to how to collect the data in the spreadsheet. Make sure to fill out the before collisions data in the red section of the spreadsheet and the after collision data in the blue section of the spreadsheet. That'll make more sense once you see the spreadsheet. It's a huge spreadsheet. Once you've completed the spreadsheet, you will transfer the appropriate data to the data table in the lab document. So you're going to use the data document to collect it and then get some like refined data. You guys know manipulated data. Then you're going to take that and put it into the actual lab document that's in your Google Docs. All right. There you will calculate percent difference of momentum and kinetic energy. You will then answer the questions at the end of the lab document. After the lab has been, yeah, that's a typo, has been completed, you will submit the file here. So this is just a submission. So if you go back to modules and you open up the spreadsheet, once it loads. Alrighty, so we're gonna open up that spreadsheet. It will open it in a different tab or a different window. And as I told you, it is a large spreadsheet because you have to record quite a few things. Let's look at what you're having to record. So first I want you to notice the first column. So we're gonna have left car, right car, elastic, inelastic, or explosion. You're gonna determine what that means as you go through. I'm not gonna give away any hints. Now, let me explain to you really quickly that this is initial condition. You input this information, then allow a collision to happen, and then you're gonna have value. So for instance, in the very first option, you have the left car is 1 kilogram and is moving 3 meters per second. The right car is 1 kilogram and is not moving. You would put left car velocity, it's given. All right, left car direction, it's right or left. All right, so if it's moving to the right, you'd put right. If it's moving to the left, you put left. If it's not moving, you put not moving, or stationary, or still. I'd just write the word still. Left car momentum is velocity times mass. Make sure if you have a momentum, assign a direction. Go ahead and assign right as positive and left as negative. Does that make sense? All right, because it's a vector. So if it's moving to the right, it has positive momentum. If it's moving to the left, it has negative momentum. The left car direction of momentum would be right or left. You're going to write out the word, but the sign should be indicative of the word. Does that make sense? All right, then right car velocity, right car direction, right car momentum, right car direction of momentum. All of that is available as you start the simulation. So that's going to be really quick. Then total momentum, add the left and the right car. This is a vector, so you'll add the positive and the negatives, and you'll be left with some number afterward. All right, that'll be the total momentum going in. And then the total momentum direction will be the sign of that momentum. So let's just say the momentum was 3 plus 3, and then you add in minus 2. The total momentum will be plus 1, and if you define plus is to the right, then the momentum will be 1 kilogram meters per second, and the direction will be to the right. That'll be the total momentum at the beginning. The left car kinetic energy is 1/2 mv squared. The right car kinetic energy is 1/2 mv squared. The total kinetic energy, add the left and the right car together. Velocity is a vector, but I want you to notice, when you square a negative, what do you get? All kinetic energy is positive. So you're going to have a total amount of positive kinetic energy. It won't cancel. All right? You'll do that for each trial. You can do this without ever running the interactions, okay? Or the interactive. You can do all this just based on these first 3 columns. I swear that keeps getting in my way. Move that right here. So you can take these left car data and right car data and fill in all of this. Now, the one thing you won't be able to fill in is bounce, stick, or explode. You'll have to run the simulation to see that. Once you've filled out the red chart, no, it's not fun, but yes, you have to do it. You can set up formulas. You guys remember how to set up formulas? All right. You'd say that left car equals, you say equals. I'd take or there's really no way to set it up to do what you need because it's got 2 numbers within the same column. But once you get momentum, you can have it calculate for you. All right, so if you wanted to calculate momentum, let me actually back this out. So I'd say this equals this cell and then asterisk, which would be Shift 8 for me. What button is that for y'all? Shift 8? Shift 8. And then you'd click direction. You'd click the mass. You never have to mention mass. So you're just going to have to type everything out. Sorry, guys. That's okay. Hey, guess what? You can do it. We've got 2 days to do this lab. If I notice that we're not done tomorrow, which will not be the case, right? Because you guys are going to go home and finish this? Yeah, you are. All right. We really don't have that much time to spend on this lab. This is supposed to be a 1-day lab. And then 1 day of review. So technically, you should take the data today in class, finish taking data tonight, answer the questions, and then we'd come back and talk about it tomorrow. But I'm going to give you 2 days in class to take data. That's a ridiculous amount of time. Most of the data comes right here. All right, so let's go to the last section, which is the actual lab document. You're going to open up that collision simulation. I want you to notice the interactive. All right, so I'm gonna maximize mine. All right, so you get to pick the velocity. You get to adjust that. That's left car. That's the red car. All right, you get to adjust velocity here. So this is supposed to be what? 3 meters per second and 1 kilogram? 1 kilogram and 0 meters per second? Isn't that the first trial? Yeah. 1 kilogram, 3 meters per second, and 1 kilogram, 0 meters per second? Mm-hmm. All right, so you're going to state elastic collision because it states elastic. It tells you which of the 3 sliders. You can pick inelastic or explosion. All right, notice what the elastic has on them. Notice what the inelastic does not have. All right, those are actually magnets. And then notice what the explosion has. It's a bomb. All right, so elastic. We've got our velocity. It needs to be set to 3. This was 0. And then we hit start. So it's going to run the simulation. And then that's the final value. It moved to the right at 3 meters per second. Then the object 1 stopped at 0 meters per second. The mass is still the same, of course. All right, then you would change you'd reset. You'd change the scenario. You'd hit start. And of course, you'd be able to record all these values because the values don't go away so long as you don't hit reset, okay? So what I would suggest you do is just to get it out of the way, fill out the red section of your data table. Make sure you've made a copy first. Don't type in mine. Did I make a view on? Let me fix that real quick. Oh, I thought you were, I don't know why, but my brain just heard you say there's a problem and I can't make a copy. That's the way my brain processed that. I've got to blow my nose. So I will make sure that we understand this one last time. You will open up the interactive, open up the spreadsheet, make your own copy, and then also have the lab document you won't need to the very end. So you can just kind of hold off on that. All right, if you want to read the instructions to make sure you know how to do that, that will be the reason to have that open. You're going to go through, you're going to fill out the red section of data. This is largely just given in these first two, or these columns right here. You're going to fill all that out, remembering that you're going to assign positive to the right and negative to the left, all right? Positive to the right, negative to the left. So positive velocities yield positive momentums, negative velocities yield negative momentums. So that when you add them numerically, you'll get a sign, either positive or negative. And if it's positive, then that means momentum is to the right. If it's negative, that means momentum is to the left. And then kinetic energy, all of it's positive, because if you square a negative, it comes out positive. So you're just adding the total magnitude of kinetic energy. Do we have any questions?
When the car's not moving and ask for the direction of velocity, just put none.
Direction of velocity would be none, in A, still, something along those lines. 0.
So do we need to do the blue?
You will do the blue after the collision. So do not run any collisions. The blue is the after collision data. So those two velocities you saw, you then record those in the new velocities. The masses don't change. So I believe, let me see. All right, you've got the occasional, make sure you pay attention to mass. Occasionally your mass will change. So just make sure you pay attention to that. But the post-collision data is largely you're taking the velocities, and the mass won't change from beginning to end. Right, so once you run that simulation, the velocities they give you above the carts are the velocities you record.